Good day everyone. So today we will discuss about the other type of two-dimensional motion, and this is called the circular motion. So here let's have a review. What is the difference between motion in one dimension and motion in two dimensions? So the motion in one dimension, as you can see here, are those motion that are strictly along the x-axis only, or along the y-axis only. So say for example, here motion towards the positive x-axis and towards the negative x-axis. The other type of motion, which is along the y-axis only, is the motion towards the positive y-axis or towards the negative y-axis. Now, the motion in two dimensions, we have here two examples. One is the projectile motion, which is already discussed in our previous meeting or in our previous lecture video. While our next topic, which is today, is the circular motion. So the difference is that the projectile motion is the motion of objects which is influenced only by one acceleration, and that acceleration is along the y-axis only, and that is the acceleration due to gravity. However, our circular motion could be affected by two different acceleration. One of these acceleration is what we call the tangential acceleration, or the acceleration that is parallel to the velocity of this moving object here, while the other type of acceleration that could be present in the circular motion is called the centripetal acceleration, which is an acceleration that is perpendicular to the velocity of this object. And we shall discuss more on these types of accelerations later in the slides. So here are some examples of circular motion. So we have here the movement of the earth around the sun. That's an example of circular motion. Of course, we have here the turning of car in concrete roads. Or of course, we also have here an example of a ride in a carnival. So, motion in two-dimensional circular motion. So in circular motion, the acceleration will not only describe the change in the velocity, the magnitude of the velocity. So, unlike our first few discussions, especially in the linear motion or in the one-dimensional motion, we have discussed that the acceleration describes how fast your velocity changes, and we know that the change in velocity is in terms of its magnitude, or in other words, the acceleration causes the change in the velocity or in the speed of the object. Now, here in in the circular motion, the acceleration not only changes the velocity or the magnitude of the velocity, but it could also change the direction of the velocity. And that is the direction in which the particle is moving. So that means we have two different types of acceleration that is actually taking place, or that is actually present in our circular motion. And now let's have this illustration. So we have here a car moving from point 1 to point 2, and this is the same car, by the way. So this is at time 1 and this is at time 2. Now, here we can see the velocity of this car. So say for example, this is now our circular path. So the car is moving in that direction. Now, the velocity of the car during this time 1 is towards that direction. But you can see that the direction of this velocity changes as the car reaches point 2. And the reason for that is there is another type of acceleration that is um, taking place, or there's another type of acceleration that is present during this motion. So let's have a closer look of these types of acceleration. So the total acceleration here is shown in the purple arrow. As you can see here, this is the total acceleration. And just like in our discussion in vectors, here we can notice that the acceleration now have two components. One component is the acceleration that is perpendicular to this velocity, and one component is this acceleration which is parallel or in the same direction as this velocity. Now, let's take a look of what are the effects of these different types of acceleration. So again, the total acceleration is composed of one acceleration that is perpendicular to this velocity and another acceleration that is parallel to this velocity. So let's look what these accelerations do. So the components of the accelerations in circular motion does two different things. So the acceleration that is perpendicular to the velocity, that means this acceleration here, is the one that changes the this object's direction. So this is the acceleration that causes the change in the direction of the velocity. While this acceleration here, the one that is parallel to this velocity, is the acceleration that causes the change in speed in the particle's velocity or in the object's velocity. In other words, this is the acceleration that changes the magnitude of the velocity. So now we have two different accelerations, and these two accelerations does two different functions in the object's motion. And of course, you can also have here a different representation of this acceleration. So if this is your total acceleration, this one is the acceleration that is perpendicular to the velocity, and while this acceleration here, the one that is parallel to the velocity, you can also put, or you can also draw them in this part here, since they are parallel to, it is parallel to this velocity. So okay, you can draw it here or here, so it's just the same. Now, any particle or object following a curved path is therefore accelerating. We can never have zero acceleration when it comes to circular motion, unlike in our linear motion. So when a particle is moving in a curved path, it always have a non-zero acceleration even when it moves with constant speed or constant velocity, magnitude of velocity. So because again, your speed is the magnitude of your velocity, right? So this first statement tells us that even though, say for example, this car is moving in constant velocity, and in our previous discussion, whenever we have a constant velocity, that means our acceleration is zero, right? That is for our linear motion or the motion for one dimension. But here in circular motion, every time an object is moving in curved path, that automatically means that it has a non-zero acceleration, because again, our circular motion have two different types of acceleration. So one of these accelerations can be zero, so that acceleration is this one. This acceleration, which is parallel to the velocity, could be equal to zero. However, every time an object is moving in a circular path or have circular motion, this acceleration here, which is the acceleration perpendicular to the velocity, this can never be equal to zero. It must always be present. So more precisely, there is a non-zero acceleration whenever the velocity changes. And we have now different types of changes in the velocity. Say for example, the velocity can change by changing the speed or changing the magnitude of the velocity. The velocity can also change in by changing its direction. So here we can see the direction of the velocity have changed. So that is already a sign that there is an acceleration. And another type of change in velocity is the change in both the speed or the magnitude of the velocity and as well as its direction. So here are the effects of the components of acceleration. Again, our total acceleration in circular motion have two components. The first acceleration is the acceleration parallel to the velocity, while the second acceleration is the acceleration perpendicular to the velocity. So the acceleration parallel to the velocity changes only the magnitude of the velocity. In other words, it changes the speed of the velocity or its magnitude, but does not change the direction, while the acceleration perpendicular to the velocity changes only the direction of the velocity, or the particle then follows, or the object then follows a curved path at constant speed. However, both of these accelerations can actually be present in one motion. So it is not necessarily that only one acceleration is present in the motion, but both of these accelerations can exist in one moving object. So if the path is curved, or we can say that if the path followed by a moving object is circular, there must be an acceleration that is perpendicular to the velocity, which is pointing towards the concave side of the path, and that is towards the center of any turn that the particle is making. So again, this one here, the acceleration that is parallel to this velocity, is not required to have a circular motion. However, this acceleration here, the one that is perpendicular to the velocity, is required in order to have a circular motion. And of course, this acceleration here, the one that is perpendicular to the velocity, must always be pointing inwards, or pointing towards the center of this circular path, and you have to remember that. So an acceleration which is perpendicular to the velocity of the object is required in order to achieve circular motion. So here we have different cases in circular motion. So the velocity and acceleration of a particle moving in a curved path. Here we have constant speed. This is for case A. For case B, we have increasing speed, and for case C, we have decreasing speed. So again, the perpendicular acceleration is required for circular motion. That's why both of these cases of circular motion has a perpendicular acceleration present. As you can see here, this one have perpendicular acceleration. This one also have perpendicular acceleration. And of course, this one still have perpendicular acceleration. If this perpendicular acceleration is equal to 0, then your object is no longer moving in circular motion. And again, this one is required for circular motion. But here we have different cases for circular motion according to the values of this parallel acceleration, because again we have two different types of acceleration here. So here in our first case, or case A, when the speed is constant along the curved path. So if the speed is constant, that means that the acceleration that causes the change in the speed, or the change in the magnitude of the velocity, must be equal to 0, which means that that acceleration is this acceleration, the parallel acceleration, which means that in our case A, there is a perpendicular acceleration, but there is no parallel acceleration. In other words, your perpendicular acceleration must not be equal to 0, again, because this is a circular motion, right? But the parallel acceleration must be equal to 0 because the speed is constant. And among these two accelerations, it is only this acceleration that causes the change in speed, right? As you can remember here in our previous slides. Now, how about the second case, or case B? So the case B is when the speed is increasing along a curved path. In such case, we still have the perpendicular acceleration, because again, this object is moving in circular path, but it has now a positive parallel acceleration. Positive parallel acceleration because the object is increasing its velocity. And now in our, the object is increasing the magnitude of its velocity, or increasing in speed. Now, how about the case C? So the case C is when the speed is decreasing along the curved path. In other words, the object is still moving in the circular path, but its velocity is decreasing, so it's slowing down. So in this case, we still have, of course, the perpendicular acceleration, but in such a case, the parallel acceleration must be negative, or it has a negative value, because again, your speed here is decreasing. So the object is actually decelerating, which means that the acceleration that can cause the change in the speed of the object, or the magnitude of the velocity, must be equal to a negative value, so that the object is decreasing, or slowing down, or decreasing its speed. So these are the different um, cases in circular motion. For constant velocity, along a circular path, we have non-zero parallel acceleration with non-zero perpendicular acceleration, but zero parallel acceleration. In the case when the object is speeding up or the speed is increasing along the curved path or along the circular path, we have still a non-zero perpendicular acceleration and we have a positive parallel acceleration. For when the speed is decreasing along the curved path or when the object is slowing down while following the circular path or while following the curved path, we still have a non-zero perpendicular acceleration, but we have now a negative parallel acceleration. So to calculate for the parallel and perpendicular components of the acceleration, say for example, you know the total acceleration but you do not know the values of the parallel and the perpendicular acceleration, these equations will be used. To calculate for the parallel acceleration, all you have to do is to multiply the magnitude of the total acceleration by the cosine of theta, while when you want to calculate the perpendicular acceleration, all you have to do is to multiply the total magnitude of the total acceleration times the sine of theta, where theta is the angle between your velocity and the total acceleration. So that's how you calculate these two components. Now, what causes the circular motion? So, in 2D and 3D motion, acceleration will not only describe the change in velocity, but it can also describe the change in the direction of the velocity, or that is the direction in which the object is moving. And you have learned in the previous slides that um, in circular motion, we have two components for the acceleration. One component, the perpendicular component, causes the change in direction, and this one is the requirement for the circular motion, while the other component is the acceleration that is parallel to the velocity, this one here, and this one is the one that causes the change in speed, or the one that causes the change in the magnitude of the velocity. So since there is acceleration, whenever we have acceleration, there must be a force applied. So this is according to the law of Newton, if you can still remember, F equals ma, which means that whenever you apply force to an object, there will be an acceleration. So this means that um, if the force is applied parallel to the velocity, it causes the increase in the speed. So if this type of force is applied to the object, then this causes this acceleration. So this acceleration is the parallel acceleration that causes the change in speed. Now, if the force is applied in perpendicular direction to the velocity, which means that if this is the velocity of the object and the force is applied towards that direction, like that, so the it changes the direction of the motion. So that means if this type of force is applied to the object, moving object, then this causes a perpendicular acceleration, which is the one that causes the change in direction. So circular motion is a result of a constant force exerted to an object directed towards the center of the circular path, and this force is called the centripetal force.